the metabolism at individual level. And then we measure with benthic chamber. This is a static method. We measure the metabolism at patch level, about 30 centimeters benthic chamber are large. In this case, we can measure the fluxes, the oxygen and CO2 fluxes at habitat level, about 100 square meter level. And then this is a really improvement respect to other types of measurements in field. These are our sites. We work in fisheries, in aquaculture. We work on the intertidal. We work with fishes. We work with seagrasses. I have a really large group, about 30 people, with different kinds of people, starting from graduate students up to associate professor working with me. This is my network. This network is a part of the Professor Dong network. And then we collaborate with different kinds of people, with different kinds of scientists, from South America to China, from China to US, from US to South Africa or just Northern Europe. As I like always, Sicily and Italy is not only science, but is also an enjoyable place where, if you like, if Professor Dong wants to push to send you, you can enjoy our places. In 2023, there was the IPCC, the Intergovernmental Panel of Climate Change, and National Unit Organization report committee produced the sixth assessment report. This is a really long report, 3,000 pages. Is done by a different kind of publication, but what is really important in this report are the reports from the three working groups: the first, the second, the third. The first is about the physical science basis of climate change currently, the impact, adaptation and vulnerability report, and the mitigation of climate change. Later, if you go to the website of the IPCC, you can find a lot of different focused reports, which are really important for us. The first thing that I want to highlight here today is that we have a strong evidence about the climate change. Climate change is now here. And then climate change, there are thousands and thousands of papers published on the climate change, and then the scientific evidence about the climate change is salient, robust, and effective. And then we need to understand how to manage the effects of climate change actually. What is really important that IPCC alerts is that the climate change is quicker respect to our ability to respond to climate change. And then societies, science, and policy are not, and economy are not well prepared to cope with the climate change, because climate change is so quick that very often we are not able to follow the pace. Climate change has a lot of different effects on water availability in the land. For example, we have different kinds of drought events in the last 2 or 3 years. We have direct effects on the health and the well-being. We have different kind of effects on our urban ecosystems, but what is more important for us is just the effects on ecosystem structure, on the species ranges or species distributions, and on the phenology of species. Phenology is the timing of species, and then how one species produce eggs, grow, and so on, different characteristics. And then we today we know that the climate change, through the increasing the temperature change, are affecting just the different kind of phenological characteristics. We know that there are different kind of projections of increasing temperature, and then the increasing of CO2 production is bringing the planet to increase the temperature. And we have a really terrible projection of about 4 degrees of increasing of average increasing of planet change. Temperature change. However, we have different kinds of solution, what we call usually enablers for effective climate action. Just I highlight different kind of solutions. The first solution, in my opinion, I am an ecologist, is just to make effective the ecosystem stewardship. Actually, we have one solution, and this is a solution to mitigate or just to cope with the climate change effects, is called ecosystem adaptive management approach. Another, climate change is not only a matter, as I said before, of modelers. Climate change is a matter of all possible disciplines, from social disciplines, or from social science to economic science, to mathematical science, to physical science, to biological science, to geological science, and finally to ecological science. What actually we need is just to combine different kind of disciplines, and then we need to have an interdisciplinary and transdisciplinary approach to understand how to manage the effects of climate change. In my opinion, the first layer, the disciplinary layer, is just biological and ecological layer. On this layer, we can build the other knowledge, the other discipline. We can use the other disciplines just to build a climate change action framework. Finally, one other important element is the international cooperation. For example, the cooperation and collaboration between two different groups, like that from Professor Dong and my group, this is increasing the ability to understand how climate change can affect the ecological responses. Okay, we have a different kind of because there are. Okay. We have a different kind of impacts of climate change in many ecosystems. We have changes in terms of ecosystem structure, space range shifts, and change in timing. And then we have different effects that can be actually measured in different food sectors. For example, reduced fisheries yields and aquaculture production includes marine and freshwater fisheries production. And then climate change actually is impacting food production sectors at global level. What is important to recall is that climate change is a pool of drivers acting and having effects at different effects with different magnitudes at the different regional level. And then in one region, we can have mitigate effects by climate change. In other region, we can have worse effects of climate change. We need to also increase our sensitivity to the words, to the keywords used in the climate change ecological science. And then our keywords are, for example, risks, resilience, adaptation, vulnerability, solutions, generative actions. This is just to develop climate change science ecology. We need to investigate different kind of aspects dealing with resilience, vulnerability, sensitivity, risks, and so on. And then let me define a bit these kind of main words, main keywords that we usually use in climate science, ecological science. Risk, for example, the definition is the risk is the potential for negative consequences for human ecological systems, considering diverse values and objectives. It's necessary to investigate the origin of risk, because the origin is different as a function of the sector, but the ecological responses are always affected, mainly starting from CO2 increasing level and increasing temperature. The increase in temperature is the main driver pushing the ecological consequences. And linked to increasing temperature, there are other aspects, like, for example, the increasing frequency of extreme events, which is now in the last 5, 6, 7 years is the new issue at global level. And then we need to know that the risk is dynamic, and then it changes with the time. And then we have other important keywords, for example, hazard, exposure, vulnerability. These kind of keywords are linked to the main ecological responses. And then this is really important. Hazard, exposure, vulnerability, and timing collectively define the dimensions of uncertainty associated with human-caused disturbance impacts on ecosystems. Another key word is really important that we know is salient and effective is uncertainty. We have not scientific elements to predict with really good level the effects, for example, of extreme events. There is a large level of uncertainty, and then is how we can try to understand to cope with the extreme events when we are not able to predict them. This is the major question. Other keywords: adaptation. In human system, the process of adjustment to actual or expected climate and its effects in order to moderate harm or exploit beneficial opportunities. In natural systems, the process of adjustment to actual climate and its effects. Human intervention may facilitate adjustment to expected climate and its effects. Resilience, another crucial word, and then there is a large room to study how to increase the resilience of ecological system. The resilience is the capacity of interconnected social, economic, and ecological system to cope with an hazardous event, trend, or disturbance, responding or reorganizing in ways that maintain their essential function, identity, and structure. The resilience in ecology is the time. The recovery is linked to the recovery time, and then when you study it when you study the stable state, the alternate stable state, and then the time during the disturbance, for example, the time to come back to the previous state, this represents the resilience. Sensitivity is really important because it's linked to the ability of every individual organism to cope with the effects of climate change drivers, and the degree to which a system or one species is affected either adversely or beneficially by climate variability or change is another important topic to be studied. Vulnerability, the propensity or to be adversely affected, and then a system can be, or some individuals, some species can be more vulnerable than other species, and this is really important to understand how to predict, how to get mechanisms about the climate change. And then our main question in climate change ecology is how to cope with the climate change effects on ecosystems. This is the most important question. And I believe that we have a solution, as I said before, is just the ecosystem-based adaptation. We need to gain an holistic view just to understand how to cope with the climate change. What is the meaning of holistic view? Holistic view is really simple, is to consider the whole system and not just one piece of the system, one component of the system alone. Is really important. And then the ecosystem-based adaptive approach deals with just the whole ecosystem. And then when you study the effect of climate change on aquaculture, for example, fisheries, on distribution of organisms, we need to consider all possible components to explain how climate change affects fisheries, aquaculture, not just one species alone, for example. And then this is the best way to cope with the issues and the issues of climate change. A recognized path to limit the effects of climate change are just the nature-based solutions, which are, what is a nature-based solution? Usually we call them restoration or remediation. Nature-based solutions are is that family of action to protect, sustainable manage, and restore natural or modified ecosystem that address social challenges effectively and adaptively, simultaneously providing human well-being and biodiversity benefits. You can see that human well-being and biodiversity are just connected because we have science about this. We have scientific evidence because biodiversity is just the cornerstone to push ecosystem functioning, ecosystem services, and human well-being. And then come back just to the second slide of this talk. Just really quickly, just to understand which are the main what we know about the effects of climate change on our ecosystems. And then from the IPCC, we know that the global temperature is increasing. In the Mediterranean, we have, for example, the temperature increased in the water of about 2.2 degrees in the last 3 or 4 years. There are different kind of effects of global increasing temperature. We have the sea level rise, for example, due to the ice melting. We have the combination of global or increasing temperature with the extreme events, for example. The extreme events are actually reality, are realistic, because we have, for example, an increasing frequency of extreme events of temperature. But this is bringing also an increasing frequency of different kind of other effects. For example, we have an increasing frequency of precipitation events. And then we have, for example, the side effects, the change in salinity in the coastal waters. If we have an increasing events of frequency of rainfall events, we have the modification of salinity in the connection between marine waters and fresh waters and the estuarine waters. And salinity is a really conservative parameter for the life. Every modification of salinity, every change of salinity, we have a strong repercussion and influence on our organism, because it is really conservative. And then in the IPCC report, for example, there are a lot of frequently asked questions, and one question is about if it is true that climate change is causing the increasing frequency of extreme events. And then is true that we have more extreme events. We have a larger magnitude of these events. We have different kind of new locations, different seas, different coasts in the world are affected by extreme events, temperature increasing, rainfall, and so on. We have a different timing, but what is really important from our point of view is that increasing events are not predictable. There is no ability, we don't have ability to predict the extreme events. Actually, we can predict the increasing temperature, but the increasing frequency of extreme events is not predictable. And then we don't know when and where the extreme events happens in the next future. And then we need to gain, for example, for you are young scientists, you need to get more science just to predict the effects of extreme events in the future. We know that we can have a different kind of extreme events. Hot extreme, they are the hot extremes that are increasing in intensity and in frequency. We have heavy precipitation, heavy rainfall, as I said before. We have increasing frequency of drought. There are different large parts of Southeast Asia, Africa, South America that are totally affected by drought. We have tropical cyclones. In the Mediterranean, for example, we are not familiar with cyclones, But in the last 3 years, we have also Mediterranean these cyclones, and then we have these huge storms that, with in increasing frequencies, are affecting our coasts. In the Mediterranean, for example, we are not familiar with strong winds. Usually, the wind in my home is never more than 50 kilometers per hour. Now we reached also 100 kilometers per hour, 150, and then we are experiencing in the Mediterranean the destruction of due to the wind storms. Maybe in the oceanic coast, just in the Caribbean, for example, in the Sargassum Sea, in the Gulf of Mexico, they are familiar, but there are different kinds of areas in the world that are not familiar or were not familiar in the last centuries with wind and storm cyclones. Now, yes. What happens at the ocean, actually? This is a really nice map showing that how our societies are depending on the coastal, on the marine resources. For example, you can see that Southeast China or Southeast Asia and China are really like Mediterranean or just other parts of the world are really strongly depending on marine resources. And then we have different kind of dependencies from coastal protection, for nutritional dependence, economic dependence. In general, we depend on our marine ecosystems, and this is crucial. There are different kinds of effects in the ocean, because we have effects in terms of increasing temperature. You remember that the chemistry of the water, the marine water, is different respect to the fresh water, because we have the salt, and then different characteristics. The marine water increase the temperature lower or just lower respect to the fresh water, but the effects are totally different. We have effects on organisms, populations, on biodiversity. We need to talk about adaptation and so on. We have an increasing temperature of different degrees in our seas. We have an increasing velocity of increasing temperature. This is crucial, because the velocity of changing the weather at local level is so important, that is affecting the responses of our societies and of our ecosystems. We have different kind of effects. For example, is expected to have an increasing of sea level. Sea level is really important, because apart from affecting some human societies, like in Bangladesh, for example, or just submerging some cities like Venice in the Mediterranean, we have a different kind of effects at ecological level. Increasing the sea level rise has effect in shallow waters like lagoons, estuaries, mangroves, and so on, because increasing the height of the water column creates the condition to discouple the benthic pelagic coupling. The benthic pelagic coupling in one lagoon of 2 meters deep depth usually is different respect the benthic pelagic clouding effect if you increase the sea level rise. We have a change in pH, for example, because we will see, you know that if you have an increasing amount of CO2 absorbed in the water column, in the water, we change the pH. We have different kinds of effect in terms of reducing oxygen. Just a really important phenomenon is called deoxygenation, which is really bad for our organisms. And also we have the oligotrophication, the reduction of the trophic level of our water masses, and then we have a reduction of the organic enrichment due to primary productivity in our seas. And then you can understand that if you combine sea level rise, increasing of decreasing pH, increasing decreasing the oxygen, dissolved oxygen level, and decreasing the amount of trophic availability, we have different factors actually in combination. We have just multiple stressors. Ocean acidification, for example, that if you have an increasing absorption of CO2, we have effects on the calcification. Calcification, the key point is 7.8 of pH. Below this 7.8, usually calcifiers or calcification organisms are not able to build the valves, to build the shells. And then this is a really important aspect. For example, we are studying these aspects in the Vulcan Island close to Sicily. And there are different kinds of vents in close to Sicily, and then we don't have calcifiers there. When you go to sites with pH below 8.2, 8.1, 8, 77.1.9, 7.8, you can follow the gradient of disappearance of calcifiers organism, but that we have more and more autotrophic organisms, and then we have more seagrass and algae. And then this is just a synthesis of our knowledge about the effects of ocean acidification of organisms. In algae, for example, we have an increasing growth. Because if you have CO2 is the food for photosynthetic organisms. If you increase the CO2, you have an increasing production of biomass, and then the growth rate is increasing. But in other cases, with heterotrophs organisms, with animals, with calcifiers, we have a reduction in terms of survival, calcification, growth, development, abundance. Actually, actually there are some solutions, because this last environmental research paper just published in 2025 showed that in Ischia, close to Italy, in Campania, close to Naples, we have some limpets that are growing better than under acidification condition respect to controls. Why? Because if limpets usually are grazers, usually eat algae, and then if you have an increasing amount of CO2 a decreasing pH, you have usually an increasing amount of biomass of algae, and limpets can eat more respect to control sites. If you we know we have scientific evidence, if you eat more, usually you are more able to contrast the effects of other multiple stressors. And then limpets here eat more because have more food for them from autotrophs, from algae, and then they are able to contrast the effects of acidification on calcification. And then they have normal shells because they eat more. This is just a last scientific evidence that biodiversity can adapt through different kind of mechanisms. What will happen in the future? I don't know. IPCC usually provide a different kind of projection, different kind of projections. We know that there will be an increasing, if we don't change our behavior, and then using what we call the business as usual scenario, we will not have important changes in terms of increasing temperature, increasing CO2 in the future. And then in the next 3 or 4 or 5 decades, increasing temperature, increasing frequency of extreme events, increasing ocean acidification, sea level rise, oligotrophication, deoxygenation will increase, will be more effective. And then in your model, we need to simulate the effects of what will happen in the future. This is really important, but is challenging to simulate what will happen in the next 3, 30, 40, and 50 years. Thank you so much, Professor Dong, and people. If you have some question, I am here. Thank you.
Any question?
50 minutes, right? Is it 50?
Yeah, no, we have 10 minutes.
Perfect.
Any question?
Yes, you're young. Please come here and then you can.
Repeat the question.
Okay.
Just curious about the ecosystem-based adaptation, because you just take some actions to protect to
Restore.
to certain management. I mean, the ecosystem. I just curious about how to evaluate or assess our action is good for the ecosystem.
Repeat, please.
Repeat.
Okay.
Because you see we take some actions to protect the ecosystem for the adaptation. I'm just curious about how do we score our actions effect. I mean, we need some doing some index or some value to assess that's our effective actions.
Okay, Yun is asking about if we have thresholds. I don't know.
I think his idea maybe how can we evaluate our efforts of restoration based on how to evaluate whether it's a success or not success. And we value the system.
Okay, how is it possible to assess the effects of restoration of a whole system in a context of adaptive management? This is a really nice question, Julian. Thank you so much. Okay, there is a recent review which is published in Nature. There are another review under review in Nature, showing that actually we don't have ability to measure the success of our action in terms of management. I mean, policy and then political advices says us that we need to protect our habitats, we need to restore our habitats, we need to manage our different kind of activities. But policy is actually more advanced respect to the scientific evidence about how is possible to do it. Okay, and this is really terrible because we don't have sufficient scientific evidence to test the ability to manage our ecosystems. However, we need to understand, and this is your commitment in the future, to understand how to increase our ability to measure the success of restoration, for example. Okay.
So maybe check are there any question?
Okay. Can you yes check it?
请问在线的同学有什么问题吗？
没有。
能听。
Right. Okay, so actually, John, I have one question. So what's the most what are the most influential climate change factor in your company?
The influence.
Yeah, the most influential factor.
And now, yes, okay. Professor Dong is asking which is the most important climate change driving effect in Italy, in the Mediterranean. I think that there are always the same drivers. We have increasing temperature is the most important, but above all, the increasing extreme events. And then in the intertidal, for example, in our intertidal, we have the combination of different conditions, because our intertidal is really small, about 40 centimeters respect to the oceans. Your experience is just meters, the tidal level. In the Mediterranean is really small, really small. And then usually we don't have a strong effect of increasing temperature of intertidal, because there is the wave washing effect that buffer the exposure at low tide. But now there are conditions for long time of calm sea, calm weather, and then our intertidal is not buffered by wave splashing because the sea is totally calm. And then our biodiversity, organisms, limpets, mussels, and so on, is experiencing a new condition in July and summer, that when there is this calm weather conditions, we don't have the buffer effect of the wave splashing at low tide, and they are exposed to the sunrise, to the sun. And then this condition is creating a new responses by our intertidal, and we have mass mortalities, for example, like as just last year that we lost a lot of different kinds of organisms from the intertidal biodiversity due to this different kind of combination of new conditions that in the Mediterranean were never experienced before.
So it looks like the Italian agents are more tough.
Yes, or more tough or just they are dying.
Okay, I think the time maybe so it's almost 11.
Okay,
So let's thank you, Gianluca, again.
okay, thank you.
So maybe say goodbye to the online.
Okay, okay, thank you so much, and bye-bye, see ya after tomorrow. Okay, thanks.
Thank you.